Hello and welcome to the last set of notes in Graphing Quadratics. We are at Graphing Quadratics number 7. So today we are going to address identifying roots. Remember that roots are zeros, are x-intercepts, are solutions. Looking at end behavior and intervals of increasing and decreasing. So we will start with the thing that we are familiar with, which is roots. And I will say it again, roots mean the same thing as x-intercepts, which is the same thing as zeros, which are the same things as solutions. All four of those things all mean the same thing. Please remember that when you have quadratics, you can have a maximum of 2 roots. That means that you could have 2, you can have 1, you can have 0, but you cannot have 3 roots or 4 roots. The maximum amount is 2. All right, so it says graph each function below, identify the roots. You need to write the coordinates for each point. All right. So we'll hop, skip, and a jump over here. I've got y equals x squared minus 9. So I've got a root right here. Oops, try again, a root right here and a root right here. So I have 2 of them located at 3, 0 and -3, 0. And then I'm going to do number 2. So I'm going to change that to a 5x and a plus 6. And looks like I'm going to, nope, try again. Looks like I'm going to have to zoom in a little bit here. So I've got one root here and another one right here. That is at 2, 0 and 3, 0. All right, I'm gonna make this for number 3 a 2x squared plus a 7x minus 4. Remember that you can pause this video and you can work ahead of me and then use the video to check to make sure that you know what you are doing. Here is a root and here is a root. So -4, 0 and 0.5 or 1/2, 0. And then the last one, I'm going to make that a plus 4x and that a plus 4. So it's just that guy. It's just the one root. Is that okay? Yes, absolutely, that is okay. You just cannot have more than 2 roots. So that is the familiar territory, looking for zeros, x-intercepts, solutions, roots. It all means the same thing. Here's a little bit of new territory. So talking about end behavior. And end behavior, this guy right here, the ends of the graph. So we are talking about what is happening on the very left side of the graph, which would be -infinity, and what's happening on the very right side of the graph, which would be positive infinity. So that is what is meant by the ends of the graph. So the very left end and then the very right end. So I'm going to have a little notation going on here. So I'm going to be using this arrow. And the arrow in math means that we are approaching, APPROACH, so it approaches, or some people will say it goes to. It's like follow the arrow, we're getting closer and closer to something. So when I talk about end behavior, I want to talk about the left side of the graph, and then I want to talk about the right side of the graph. So I'm going to talk about the left side first because I always start smallest to largest. So check it out. As x's go to the left, as my x's go towards negative infinity, that means that I'm going off as far as I can to the left. My f of x values, remember, that's the same as y values. Those two things are the same thing. My y values are going off to where? So if I follow this graph and I follow it to the left side of my graph, I'm going farther and farther and farther left. Where is this going in the y direction? It is going up towards positive infinity. That is end behavior. As I go super far to the left, which direction is that heading in the y direction? So as I go closer and closer to the left, that's a y value. Where is my sorry, I think I said that wrong. As I'm going farther and farther to the left, which is an x value, where is my y value going? All right, let me do the right side. So as x's get closer and closer to the right side, which is positive infinity, where are their y values going, or their f of x values going? So think about it. As I follow this graph farther and farther to the right, what y value is that going to? That is going to positive infinity. So that is called end behavior, analyzing the left side of the graph, analyzing the right side of the graph, and telling where do the y's go? Are they going to positive infinity? Maybe they're going to negative infinity. Maybe you have one side going to positive infinity and the other one going to negative infinity. It just depends on the graph. All right, let's take a look at number 2. So I'm going to start on the left side first. So as x gets closer and closer to the left side, which is negative infinity, where is the graph heading to in the y direction? It's going down. So that would be negative infinity. And now I'm going to do the right side. So as x's get closer and closer to the right side, which is positive infinity, where are those y values going? Well, they're going that direction, which means that they are going to negative infinity. Let's take a look at number 3. It says graph the function and describe the end behavior. So I know a couple of things. I know that that is a frown. And I know that that is my y-intercept. So just off the top of my head, I know that my y-intercept is 5, and we are going to have some sort of frown. I don't need to have to, try again. I don't have to graph it exactly because I'm just looking at the behavior of the ends. So what is our left side behavior? As x's are going farther and farther this way, so as x's are approaching negative infinity, where's the graph going? It's going down, which means that your y values are going to negative infinity as well. And now let's do the right side. So as my x values go farther and farther to the right, which is positive infinity, where's the graph going? Graph is going down. So that is negative infinity. So as you go closer and closer to an x, what y are you getting closer and closer to? That is called end behavior. What is happening at the ends, the very left side of the graph and the very right side of the graph. Okay, so the last thing that we need to talk about are intervals of increasing and decreasing. So we did a little bit of this in Math 1 last year. So we're going to go over it again, this time with, instead of linear, which is what we were doing in Math 1, now we're going to do it with quadratics. So if you read a happy face, so a smile, let me give you a smile. If you read a happy face from left to right, because we always go from smallest to largest, so that means that we always start on the left and go to the right. Oops, sorry. Okay, so I got my smiley face, my happy face here. So as I read it from left to right, left is smallest, right is largest, then this is what happens. The graph is decreasing all the way until it gets to the vertex. And then it changes directions and now begins to go up, which means that it is increasing. So if we're reading a smile, then that means that we are going to start with a decreasing function. Then we hit the vertex and it changes to an increasing function. So decrease means that you are heading down and increase means that you are heading up. So if I look at a sad face, a frown face, and again, I'm starting on the left side, the small side, I am following the parabola up, which means that it is an increasing function until it hits the vertex, and then it changes directions and heads down, which means it's now a decreasing function. So what we can do is we can create intervals that tell us when a graph is increasing and when a graph is decreasing. And these intervals we talk about as x values. So the intervals are going to be over a span of x's. An interval, I'm sorry, the graph is going to be increasing or decreasing. So it says, for each below, identify the vertex point, sketch a graph, and then identify the intervals on which it is increasing or decreasing. So a little review here. This is in what form? Vertex form. So that is your A, and that is your H, and that is the K. And remember that for vertex form, H comma K is your vertex. Also remember that H is always the one that is opposite. So that means that my vertex point is going to be at opposite -1, -8. So if I just do a rough sketch, I'm at -1 down here at -8. And my A value is positive, which means that we are dealing with a smile. All right, so as I start on the left, my graph is going to be decreasing all the way down to this x value, which is -1, right? That is the axis of symmetry, -1. So that means that we are decreasing from -infinity all the way to where x is -1. And then once we hit -1, our graph turns upwards and we are now increasing. So starting at the vertex -1, we are increasing until positive infinity. These are x values. I'm going from the very left, which is -infinity, all the way to the vertex, and then all the way to positive infinity. All right, let's take a look at number 2. So I've got A, H, and K. So that means that opposite is +2, and then K is missing, which is 0. So I've got a vertex point at 2, 0. It is a negative, which means that we are dealing with a frown. And this x value right here is 2, right? That is my axis of symmetry at 2. So here it goes. I'm starting on the left side of the graph, and my graph is increasing. It's going all the way up to the vertex. So starting at the left, I'm increasing. So starting at negative infinity and making it all the way to an x value of 2, that's the vertex. And then once I get to the vertex, that becomes a decreasing function. So starting at x is 2, I'm going to go all the way to the right, which is positive infinity. Number 3, I've got A, H, and K. So opposite is 4, comma 2. So I've got 1, 2, 3, 4, 1, 2. So here's my vertex. A negative A value means that this is a frown. This x value is at an x value of 4. That would be your axis of symmetry. So starting on the left side of the graph, this is an increasing function. So increasing, left side of the graph is negative infinity, and it goes all the way to an x value of 4. That's when I run into the vertex. And then starting at my x value of 4, it turns to a decreasing function. So starting at an x value of 4, I'm going to continue on to the right, which is positive infinity. These are all x values. The increasing, the decreasing, that's talking about y's, and I am reporting their x values. Last one. Let's see, I have an A and an H, and that's K. So I'm missing the H, which is 0, and K is negative 5. So I've got 0, negative 5 down here. It's a positive A value, which means that we are smiling. So if I start on the very left side of the graph, we are decreasing all the way to the vertex, which is at x equals 0. So decreasing from the left all the way to 0, and then increasing from 0 all the way to the right. So from 0 to positive infinity. And that, ladies and gentlemen, wraps up all of the things that we need to know about quadratic equations.